The joint project with AVEVA helps us to be prepared for the competition of the future. It helps us to prepare our employees, apprentices, to be familiar with virtual methodologies in terms of learning. From a company point of view, by using OTS, IMS, we have the possibility to ramp up the number of apprentices due to demographic change. We need a significant number of well-trained, well-prepared people.
The training challenges was to insert these modern technologies into our training habits. Before it was practical training on site. We have these training departments, smaller copies of big production plants where we can train our apprentices.
The augmented reality system is a duplicate of the real system, so everything you can do in the real system can be done in the augmented reality.
And we needed it quite fast, so the development of this VR solution took 6 to 9 months, and in that time we couldn't have built a new technic hall.
Areas where we train chemical operators, we talk about huge investments. When we use virtual reality, this gives us the advantage to increase the numbers without these big investments.
However, the augmented reality system includes additional aspects like explaining what's going on inside of the equipment. You can see inside of the equipment like a distillation column where you can see how the heat and mass exchange is taking place between the gas and the liquid phase.
The project started out of this industrial 4.0 aspect a couple of years ago. It started with bringing all these new modern technologies into the industrial world and also into the training area. We implement all these technologies into our factories, and so we actually fit perfectly into the company's strategy for developing in this area.
Digitalization is a big thing in BASF, and we want to be state-of-the-art in our training procedures, and that's why we created, together with AVEVA, the virtual reality project, which gives us the opportunity to have the training in a real workshop and in the virtual reality.
What I really like is that the system really guides you. So even if you don't have any experience with this kind of chemical plant, the system will tell you where to go, it will tell you what to do. It gives you detailed explanation and animations of different parts of your chemical plant, for example, different types of pumps. And this is something I really liked. And in my personal experience, the learning effect was way better than just given like a theoretical introduction. It's kind of our future. 3D models, virtual reality, those are topics that are coming in the future or are already there here in the BASF.
Digital transformation is very important for BASF's future success. This is also the reason why digitalization is one of the pillars of BASF strategy. But digitalization without people who are capable to work with digital instruments cannot work at all.
The scope was twofold. On the one hand side, it includes the real process equipment where all the chemistry, thermodynamics is going on, and on the other side, the process control equipment where control is done by the employees in this training facility. The key challenge from a BASF perspective was to make a decision either to duplicate the existing system or to move into an alternative training concept. Obviously, it's always a possibility to duplicate the existing system, but this can be quite expensive as this is real equipment.
Due to this VR application, we could increase our capacity in our real training facility because we skipped 1 week, and in this week we could train another class. So in the end, we had both two benefits. We had these modern technologies in our training environment, and we could increase our training capacities in the end.
Benefit for the trainees is that they work with state-of-the-art technology. In the virtual reality environment, we have the possibility to create additional content which they cannot have in the real workshop.
Our apprentices, they are in average 18, 19 years old when they start. And they knew these technologies. They come from at home, from their gaming environment, gaming consoles. They know this technique, and they are very, very eager to use these modern techniques also for learning purposes.
It's a digital twin of a real training facility.
The young apprentices, they are very eager to work with the system. They have less fear. They just jump into this virtual plant and to do the switches and operate the plant. And when they later come into the reality, they are less feared to do something in the real world. It was beyond our expectations. The sustainability in this training procedure is, of course, that we save all the chemicals that we insert in the reality. So we do not need them anymore. In the VR, you just push the button and there are no real chemicals are been used for the reactions. So we save that. We save a lot of steam for heating up processes, for example. We save cooling water in the end. And as said, you can repeat it more often. And every time you save all this stuff for the environment.
This is in terms of economics very good, but also in terms of the training quality. It helps us to prepare young people for the smart future, for smart manufacturing and chemical industry.